This video is going to be a review of quadratics and your parabolas. First thing to remember is that there are two different ways to write the equation for a parabola. There is the standard form, your ax squared plus bx plus c. This is useful for finding x and y intercepts. This is when we use the quadratic formula to figure out where the parabola is going to hit the x-axis. And then you can easily see the y-intercept is right at the end here. However, when you're graphing these, it's hard to see where you're going to start. You can't easily tell by looking at the equation where the vertex is. So the other way to write an equation of a parabola is the vertex form. And so this is y equals a and then times x minus h squared plus k. This is useful for graphing. You can easily see where the vertex is and what the stretch is, and so you can get the general shape. The one thing that both equations have in common is a, your stretch factor. So just from looking at this value, you can tell if your graph is going to be skinnier, wider, or flipped. Just remembering that if this number is greater than 1, it'll be skinnier. If it's less than 1, it'll be wider. And then if it's negative, it is going to be flipped upside down. So let's practice a couple of graphs of sketching parabolas. So we have y equals 3 times x minus 2 squared plus 1. So the first thing to remember is that your vertex is going to be at 2, 1. You take the opposite of what is in the inside. You have to remember that x minus 2 means shift the graph to the right. And so take the opposite to get that x value of the vertex. So I'm going to plot that at 2, 1. And then the stretch factor helps you with your next point. You can actually go over 1 and then up 3 for your next 2 points. And this only works from the vertex one time. You don't keep continuing this. If you were to continue this, then you'd get an absolute value graph. And so we want that curve. So only do this for the points 1 over from the vertex. So then when I connect the points, there is my parabola. Here we have y equals negative 2 times x plus 1 squared minus 3. My vertex is at negative 1, negative 3. Remember that you have to take the opposite of what's in the parentheses. And so I'm going to plot that point at negative 1, negative 3. And now that you have a stretch factor of negative 2, you should know that your graph gets flipped upside down. But the other way to look at it is I'm going to go over 1 and down 2 in each direction from my vertex. So I'm going to plot those 2 points. And there is my parabola. And then the third graph that we have, y equals 1/2 times x plus 4 squared plus 2. So your vertex is at negative 4, 2. So I'm going to plot that point. And then with the stretch factor of 1/2, this is a little different. You would usually go over 1 and up 1/2. But if you don't want to deal with the fractions or the decimals on your graph, the other thing that you can do when your fraction is 1/2 is to go over 2 and up 2. And so then you can tell when I plot these and connect them that my graph is a little wider than the previous 2 graphs. It's going to be helpful to be able to convert back and forth from your standard form to your vertex form. So here's an example from standard to vertex. So you can complete the square or you can half square subtract. So I'm going to show you what to do here. So the half part is you take half of the middle number, so your b value, and that is actually the x value of your vertex. Now this works if your stretch factor is 1. So if there's any other number out in front of x squared, this isn't going to work, and I have a different formula for you. So after you've halved the middle number, then you're going to square it. So 2 squared is 4, and I'm going to subtract that from the end value, that negative 3, and that gets me negative 7, the y value of my vertex. Let's try another one. Y equals x squared minus 6x plus 1. So the first thing I'm going to do is take half of that middle number, and I get negative 3. That goes down into the parentheses. And then I'm going to square that, and I get 9, and I'm going to subtract that from that 1 at the end, and I get negative 8. And so then my vertex is at a positive 3, negative 8. Now, if you want to go the other way from vertex form into standard form, all you have to do is follow order of operations. So you do x minus 3 squared, you'd either do box or your FOIL method, and then at the very end, combine like terms with your 8. So if your stretch factor is something other than 1, you can't use the half square and subtract method. Instead, you have to use this small formula to find the x value of the vertex first, and then you just plug that back into the equation to find your k value. And so if your stretch factor is something other than 1, you do h is the opposite of b, so the opposite of that middle number, divided by 2 times a. So here's our example. We have 3x squared plus 6x minus 7. So I want to convert this into standard form. The one thing that is nice is that the stretch factor remains the same. So if a is 3 in the standard form, it should be the 3 in vertex form as well. So now my h, what goes in the parentheses with my x, is going to be the opposite of b, so a -6 divided by 2 times 3, so 2 times a, and I get 6 here, and that's -1. Well, then this becomes a +1 in my parentheses because you're subtracting a -1. And then I need to plug this value into my standard form equation to solve for my k value. So I'm going to do 3 times -1 squared plus 6 times -1 minus 7, and I get -10, and then that just goes off the end, and that's the k value. So my vertex is at -1, -10. One more example of converting from standard to vertex form when there is a stretch factor other than 1. You have your a and your b. Your 2 easily translates to vertex form. So then remember your h is your opposite of b over 2a. So since my b is -8, it becomes a +8. And then 2 times 2 from your a value, you get 8 divided by 4 is 2. And so I get x minus 2 in my vertex form. And then I need to plug that 2 into the standard form equation for x to get my k value. So 2 times 2 squared minus 8 times 2 plus 5, and I get -3. So my vertex is at 2, -3. And then the last things, knowing how to find important points on a quadratic. So your vertex, your x-intercept, your y-intercept, and then also knowing your domain and range of your parabola. So remember that your vertex is the opposite of b over 2a, or you could also do the half square and subtract, and then just plug that value in to find the x or the y value of the vertex. X-intercepts, that's when your y equals 0. And so here you would either use the quadratic formula in your calculator, or you could factor it and use the zero product property. Your y-intercept is when x equals 0. So if it's in standard form, that's easy. That's just the very last value. And then you could also use this for vertex form, but then you just have to do your order of operations. Domain for all parabolas is always going to be all reals, or -infinity to infinity. And then your range is going to vary depending on your stretch factor. So if your stretch factor is positive, your range can either be y is greater than or equal to k, or k to infinity. This is called interval notation, if a is positive. And then the other way is y is less than or equal to k, or -infinity to k if a is negative, meaning you've flipped your parabola upside down. So let's do one example together. We have y equals x squared plus 2x minus 3. So vertex, you can do the half square subtract, or I can do the opposite of b over 2a. This does work even if your stretch factor is 1. And so then my k value, when I plug -1 up into the original equation, I get -4. My x-intercept, since it's factorable, my vertex is at -1, -4. Since my x-intercept or my equation is factorable, what multiplies to a -3 and adds to a +2, I'd get a +3 and a -1. So this is the factored form of a parabola. And then zero product property, if I set each of these parentheses equal to 0, I take the opposite. So I get -3 and +1 as my x-intercepts. My y-intercept is just that very last number in standard form, nice and easy, because when x is 0, it's going to wipe out these first two parts, and you're left with -3. Your domain is always going to be all reals. And then your range, because you have a positive stretch factor, that means you have your normal U-shaped parabola. So my vertex is the lowest point, and so my range is going to be y is greater than or equal to -4. Go ahead and try the second example on your own, and then go to Moodle to do your homework. Have a great day.